In this experiment, we are breaking Christmas tree ornaments. One down. Okay. We're going to measure the, we're going to observe, we're going to take measurements that allow us to calculate the potential and kinetic energy changes as a cart, or the friction car, accelerates from rest down the incline. Now, by measuring the distance that the front of the car travels, and by timing the car using the pendulum timer preferably because it gives more accurate results than the computer timer, we can determine how long it takes the car to go a given distance from rest, assuming a uniform acceleration, which we've established by other measurements. We can determine then the average and the final velocities of the car, and therefore the increase in its kinetic energy. By using a line level with the shelf standard balance beam, we can measure the difference in the altitude from this end to this end. We want this thing to be level, and when we have it level, then the difference in altitude will be just what we measure here. From that, we'll be able to determine the potential energy change and make comparisons. And another part of the experiment that I'm not going to demonstrate just involves doing a very similar thing, but rolling one of the steel balls down the grooved incline. Okay, could be the shelf standard balance beam, could be the curved end incline. And in that case, we actually measure the final velocity not by how long it takes the object to move down the ramp. For example, if we use the curved end ramp, we wouldn't have uniform acceleration, and the time wouldn't really tell us it would tell us the average velocity, but wouldn't tell us that much about the final velocity. We infer the final velocity by the projectile behavior, as you've seen in another experiment, by allowing the ball to go off the edge of a table and measuring its range with a known height. You determine the horizontal velocity with which the ball left the ramp. So using these means, we're going to do some determinations of velocities and altitude changes and infer potential and kinetic energy changes, and you'll also be thinking about why maybe the kinetic energy change is not as great as the potential energy change in magnitude due to some friction and so forth.